Okay, 5.2. We're going to start with geometric or 2-column proofs. 2-column proof is again a formal proof that contains statements and reasonings organized in 2 columns. So statements and reasons. So here's one of our examples here. So writing a 2-column proof to show that it is if 2 angles are vertical angles, then they have the same measure. So you are given that lines M and N intersect. That's all you're given. And that 1 and 3 are vertical angles. So they're across a vertex. You need to prove that angle, or the measure of angle 1 is equal to the measure of angle 3. So I have 2 columns here, and one is statements on the left and one is reasons on the right. So the first one is going to be the easiest. The first one is going to always be your given. So whatever you're up here, you're just going to restate. The next one, 1 and 2 are a linear pair. So sometimes when we have stuff in like geometric proofs, you're going to have to figure out what is a linear pair. It's not something that we've talked about recently. It might be something we haven't even talked about this year. If you don't know something, look it up. And a linear pair is are 2 angles that create or lie on it's in the name. It creates a line. Linear pair are 2 that create a line. So the reason is, why is 1 and 2 a linear pair? Because they create a line. And that's going to be the definition of a linear pair. 3 and 2 are a linear pair. Definition of a linear pair. It's background knowledge on how I get to that point to prove it. I need to write down all the facts that I can. Okay, 1 and 2 equal 180. Why? Why do 1 plus 2 equal 180? It's a straight line. It's the definition of supplementary angles. Okay, 3 plus 2 equal 180. Again, 3 plus 2 equal 180. Definition of a straight line, supplementary angles again. Okay, 1 plus 2 is equal to 3 plus 2. 1 plus 2, if I look here, 1 plus 2 is equal to 180, right? So I'm going to substitute, instead of 180, down here, I'm going to substitute this part right here into this 180 spot, because it also equals 180. So I'm substituting it in. Now, what's happening from this D to E? Here I have 1 plus 2 equals 3 plus 2. Here I just have 1 equals 2. Angle 1 is equal to the measure of angle 3. What changes? What is being taken off of this statement to this statement? Those measures of angle 2. So again, if you take something away, Marcus, sit up. If you take something away from both sides of an equal sign, it stays equal, correct? So therefore, it's the subtraction property of equality. And I just proved what they wanted me to prove, that the measure of angle 1 is equal to the measure of angle 3. Measure of angle 3. Okay? The next one, the statement for a 2-column proof to show that if the measure of angle Y, so right here, is equal to the measure of angle Z. Again, Y and Z are just names. Then X is equal to 100 are given below. Complete the proof by providing the reasons. So it gives you, you're proving that X is equal to 100 here. But you need to tell me all the reasons. Well, first, that M is equal to Z y is equal to 2x minus 90, and z is equal to x plus 10. Why is that? What is the reason behind that? You need to be taking notes. I would get your notes out. Because if I catch you with your eyes shut again, it's not going to be good. Why? This is all what type of information? It's all given. So given information, that's going to be the easiest one to write down. Okay, next, 2x minus 90 equals x plus 10. Why? How do I know that those two are equal? Looking here, these two are equal, correct? Then this is equal to this one, right? So pretty much this could be replaced with a z, right? So therefore 2x minus 90 is equal to x plus 10. If this equals this and this equals this, then this have to equal this, right? So that is called, that we're going to use substitution for that. Okay. Now, x minus 90 equals 10. Why? What happened from this one to this one? Well, I got rid of not yet. I got rid of an x on this side and an x on this side, right? So what I did was I subtracted the x. So that's going to be subtraction property of equality. Oh, I went off the page. Now, how did I get from this x minus 90 equals 10 to x equals 100? What happened from this step to this step? How are you going to solve for x? Think about that. I would add 90 to both sides, correct? So that would be my addition property of equality. Okay? We just proved that x equals 100. We just proved it. Okay? The last one before we work on homework. How much time do I have? Plenty of time. On here I have 7 minutes. All right, so refer to the figure above, this information up here, complete the 2-column proof to show that EG is equal to 3x minus 1, ED is equal to 2x plus 4. Oh, sorry, I missed that. If these two, then EG is equal to ED. Oh, wait, so this is all given information. You want to prove this part right here. And if you look in my statements, it's my last statement. So this is what I do want to prove. My first statements are always my what? It's my given information. Now, how do I know this? How do I know that 3x minus 1 is equal to 2x plus 4? What did I do with this information up here? I substituted. Then, from here to here, what did I do? I took off, I got from 3x to x. I subtracted how many though? I subtracted this 2x, right? I subtracted it from both sides. So that would be my subtraction property of equality. Okay? Again, what did I do from x minus 1 equals 4? I'm adding 1 to both sides, correct? Addition property. I forgot property up here. Property of equality. Okay, so your assignment is not very many, but it's kind of longer problems. Page 383, 1, 3, 11, 13, and 15. Okay? You need to work on your own.